Alright, I believe this is the last thing we're going to do on section 2.6, which is part C. So let's do one right off the bat. We're going to solve again. This whole chapter is about solving for x. And then it's 15 minus 2x. Alright, if you take a look at this, there's a couple things that are, I don't know, kind of in our way, I guess, to solve for x. What's the main thing that you see that's kind of in your way that you got to get rid of? The square root, absolutely. Okay, we want to get rid of the square root. Now, also notice that you have an x on one side of the equal sign and an x on the other side of the equal sign. So eventually, maybe not in the first step, but eventually we're going to have to get x on the same side. Would you agree? All right. But our first roadblock is that square root. So we know, we've kind of did that actually earlier when we did the, when we went over that worksheet. It didn't look like a square root, but we had something to like the 1/5 power, didn't we? Okay, how'd you get rid of something to the 1/5 power? You took it to the 5th. So the square root, how would I get rid of the square root? Take it to the 2nd, that's right. So we square it because that undoes it, right? It cancels it out, a lot of people like to say. So what we're going to do is we're going to take the square, we're going to square this side, and we're going to square this side as well. Now, as long as all that stuff is under that one big square root, that whole square root just goes away. So let's see what we get. We get x squared equals, look, that whole square root cancels out, and so I've got 15 minus 2x. So that helps a little bit. Now, this kind of looks like something we've been working with, doesn't it? Except it's not exactly in the exact form that we want it, but we can very quickly and easily make it into that form. Kind of looks like a quadratic. It looks like an x squared, an x, and a constant. So let's make it look like we want it to. So we'll keep that x squared right there since it's already positive. Let's take this minus 2x and move it to the left side. That'll make it a plus 2x. Let's take this 15 and move that to the left side. That'll make it a minus 15. And what's it going to equal? If I take both of these things and move it over here and move this over here, what am I left with? A 0. Now this looks very familiar, doesn't it? So we go ahead and we solve. So we've got an x here, let's say, oops, let's go plus 5 and minus 3. Does that work? Yep, because that's negative 3x plus 5x is positive 2x. Perfect. So we set these both equal to 0. We can do this in our head. That's negative 5, and that's not negative, but positive 3. Now you got to be careful on this stuff. Here's one thing that I need to show you. When you square both sides, sometimes weird things happen. Alright, sometimes weird things happen, and even though we did all this math right and we got 2 answers, sometimes sometimes both of these answers don't work. Sometimes they do. Alright, sometimes both of the answers are completely fine. Sometimes only one of the answers works. Sometimes none of the answers actually work. So how am I going to determine if these answers are the right answers or not? Plug them back in. That's right, I got to plug them back in. Alright, what was our original problem? Our original problem was this, wasn't it? Okay, so what we're going to do is we're going to plug these numbers back into this and see if it, so was that. We're going to plug these numbers back in. How do you know when to plug the numbers back in? When you square both sides, that gives you an indication of, hey, wait a minute, I better plug the numbers back in to make sure that they both work. Because sometimes they both don't work. Sometimes they do, sometimes they don't. So let's plug them both in. Let's try the negative 5. So it's 15 minus 2 times negative 5. Well, what's 2 times negative 5? It's negative 10. And that's what? Everybody see that? It's minus 2, right, times negative 5. Just plugging it back in. That's plus 10. 15 plus 10 is what? 25, isn't it? All right? And what's the square root of 25? It's 5, isn't it? Well, technically it's plus or minus 5, right? It's positive 5 and negative 5. Well, what do we say x is equal to? It's negative 5. So let's check. Does negative 5 equal plus or negative 5? Well, it does equal negative 5, doesn't it? But does negative 5 equal positive 5? No, it doesn't. All right? So technically this doesn't work. It works a little bit, but it doesn't work for every single one, okay? Because negative 5 doesn't equal positive 5, so we cannot say that that works. So we can't use it. We cannot circle it. If you circle it and include that as one of your answers, it's going to be wrong because that does not work. Okay? Let's plug this one in. Actually, I did that plus or minus thing. We're just going to go with the positive version of this. there's explanations to this. I'm not going to go through it, but if it just says the square root of 25, we'll just say it's 5. So does negative 5 equal positive 5? No, it doesn't. All right, let's plug a 3 in and see if that works. So it's 15 minus, yeah, so that's 15 minus 2 times 3. 15 minus 6 is what? It's 9, isn't it? And then what's the square root of 9? It's 3. So does 3 equal 3? Yes, it does. So that does work. So I'm allowed to circle that, and that would be my answer. So the trick on this problem is not just solving for x, but once you get your answer, you got to plug them both back in to see if that answer actually works. Because sometimes both of the answers actually do work. Sometimes only one of them works, and then sometimes none of them work. Does that make any sense? There's explanations as far as graphing and that kind of thing. In Algebra 2, we went through that. I know you didn't have me for Algebra 2, but I'm not going to go through that. Just believe me, you got to plug them back in to see which ones work. All right? Good, good, good. All right, let's try another one. So that wasn't too bad. Let's go back. Actually, take a look at it. That wasn't too bad because everything inside, or everything right here was under one big old square root. And this didn't have a square root with it. But this next one looks a little bit different. So let's take a look at this example. And you're going to probably want just to take this, or to square both sides right away. But you got to be careful with that. Again, over here, wow, I skipped way down, didn't I? Over here, you can square both sides because look over here on the right side. Everything on this right side is under one big square root, isn't it? Okay, I'm saying that on purpose because what you're going to see here in a second. Everything on that side is under one big square root. Even though that there's a minus in between these two, all of this is under one big square root. If you look to see what we wrote down right here, look on this left side. Is everything under one big square root on this left side? No, they're two square roots and they're being separated by a minus sign. Everybody see that? You got to be really careful with that. They're being separated by either a plus or a minus. All right. If this was a plus, the same thing would hold true. So you can't just square both sides. It would be nice if you could just square this, and square this. But that doesn't work. All right. That's not algebraically correct to be able to do that. You can't just square this and this. What are you going to have to do though? If you want to get rid of the square roots, you will have to square it, but you're going to have to square this whole entire side. Now that gets real complicated. So I'm not going to square this whole entire left side. Technically you could do it if you wanted to, but it's going to make it real complicated. What I'm going to do is this. I'm going to take this, just to make it a little easier for us. I'm going to take this and I'm going to chuck that to the other side. Yep, you said it. I'm going to add it to the other side. You got it. So let's see what we get now. I get the square root of 2x plus 3 equals... Watch, I already had a 1 over here, didn't I? So I'm going to keep it right there, put a plus, because I'm adding this to put it to the other side, and this is the square root of x plus 1. Now you may not look at this and say, oh, that looks better than it did before, but it actually is. It's actually better than it was before. But again, what do we have to do? We got to get rid of the square root. Well, look at the left side. Can I just square the left side to get rid of the square root? Sure, because look. On the left-hand side, everything is under one big square root, isn't it? So absolutely, I can square this side. If I square this side, it's going to get rid of the square root. But you got to be careful. Can I come over here and just square that? Or just square that? No. I have to square the whole entire right side. I squared the whole entire left side here. I got to square the whole entire right side. So what does that mean I have to do? Put parentheses around it, absolutely. Put parentheses around it and square that. This is where it gets a little complicated, and unfortunately, I could really use about 5 more minutes, and we don't have it. But let's do the next step, and maybe I'll let you work on it a little bit, and we'll pick it up tomorrow. Okay? So what's going to happen here when we square the square root? Cancels out. So I've got a 2x plus 3. Now look at this. I'm going to start the step, and I want you to try it tonight. All right? What am I going to do here? Am I just going to square the 1 and square this square root? No. What do? Give me a good word. It's a word that stands for 4 words. It's FOIL. That's right. We got to FOIL it. But before I FOIL it, let's write it down. Because when I square something with a plus or a minus in between, right, we've done this before, I've talked about that a lot. We have to multiply it by itself. When you square something, you multiply it by itself. So what we have is this: 1 plus the square root of x plus 1, and then another 1 plus the square root of x plus 1. Everybody see that? Now look what you're going to do here. I'll just give you a hint. I want you to try this tonight. All right, so you're going to do this. You're going to go first, right? Then you're going to go outside. Then you're going to go inside. And then you're going to go last. Once you do that stuff, you're going to come up with a quadratic. And then you should be able to solve that quadratic and get x by itself. All right? So it takes a little bit of extra time and effort, but I think a lot of you can do that. Try it tonight. We'll pick it up tomorrow, okay? Right where we are. I'll actually save this lesson, and then we'll pick it up tomorrow. But I want you to try it. Just don't come in here. I'm not giving you homework. This is your only homework to finish up this problem. All right? Then I'll give you a worksheet tomorrow.